In this video, we're looking at scientific notation. Scientific notation allows you to take large numbers and small ones and rewrite them without the need to carry all of these additional zeros that you can see that come after and before those numbers. So just before we start, we'll have a look at the basic convention. If I took the number 2, I can rewrite 2 as the number 2.0 if I like. We're going to be using this kind of thing a lot. Now, if I said I want to multiply 2 by 10 to the power of 3. Okay, what does that mean? How big am I going to make the number 2? Well, 10 to the power of 3 simply means, we've seen this in the last few videos, it's 10 times 10 times 10. So you've got 1, 2, 3 zeros. So you end up with 1,000. So when I say 2 times 10 to the power of 3, what I'm really saying is 2 multiplied by 1,000. At that stage, you just need to add those 3 zeros onto the end of the 2, and you end up with this. You get 2, 1, 2, 3. 3 zeros there, you get 2,000. So coming back to this original part, when I say 2 times 10 to the power of 3, all you really need to do is go, okay, I'm going to add 3 different zeros onto the end of that 2 there, and you end up with your answer straight away. So if I give you something like this, 4.0 times 10 to the power of 5, well, all that really means is you're going to take your number 4 and you're going to add 5 zeros onto the end. 1, 2, 3, 4, 5. You've got 5 zeros there, so you end up with 400,000 as your number. But we've automatically gone and simplified it by saying it's really 4.0 by 10 to the power of 5. So let's have a look at some of these over here. The speed of light travels at 300,000 meters every second. So that means 300 million meters per second. What I'm going to do is turn that into scientific notation. So if we split up these numbers, what we really see is something like that. Exactly the same amount of numbers there, but it's a lot easier to work with it if we look at it like this. We take our first non-zero number, which is 3, so it's equal to 3. And now we have to find out how many bounces down we make before we get back to that decimal. So the decimal's currently here, and we're going to be putting the decimal right in here. So we can look at it like this if you like. It's going to be 3.0 by 10 to the power of something. Okay, so what I'm going to do is I'm going to bounce these decimals down here. I've got 1, 2, 3, 4, 5, 6, 7, 8. So our decimals moved 8 places. So I'm just going to write this as 3 times 10 to the power of 8. Down here we've got the thickness of a human hair. Now this is on the other end of the scale. Instead of having a very large number, we've got a small one. But we can do exactly the same thing. What I'm going to do is I'm going to write it as 1.0, but this time the decimal has to bounce the other way. So if we space that out, we see this number here. We need to get our decimal down to here. So it's 1.0. So I'm going to have 1.0 like this. And we're going to bounce this decimal down how many times? We've got once, twice, 3 times, 4 times. Now you can see I've bounced the other way in this case because it's a small number. So it's still going to be by 10 to the power of 4, but that power of 4, we now make it into a minus 4, okay, because we've gone the other way. It's a small number. It's less than 1. So here we've got 3 by 10 to the power of 8, indicating you've got a large number. It's a positive indice there. And here we've got the negative indice, meaning that our number is less than 1. So over here we've got the diameter of the sun is equal to 1.39 by 10 to the power of 6. I want to write this without scientific notation. I just want to turn it into the basic numeral without the power. So what I'm going to do is I'm going to rewrite it first of all as 1.39. Now is it going to be a very large number or a small number? Well, you can see it's positive, and just like up here we had that positive number, it meant that we had this very, very large number. So over here we're going to be adding all these zeros to the right hand side. We're going to be moving that decimal down. So let's find out how many bounces we have to make. There's 6 there, so I'm going to start bouncing it down. I've got 1, 2, 3, 4, 5, 6. So our decimal is now going right here below that arrow there, and I have to fill up all these other spaces that are missing with zeros. And if you want, you can put another 0 on the end, but you just need to realize that it's really going to be, well, I've got 3 zeros there, and we have another 3 zeros here. So you've got 1,390,000 kilometers. That is the diameter of the sun. So I'll rewrite it now without that decimal here. We've got 1,390,000 kilometers. So there, the diameter of the sun is 1.39 by 10 to the power of 6, or 1,390,000 1,000 kilometers. So the last one is the weight of a feather. We've got 5.1 by 10 to the power of minus 4. So minus 4 means you're going to be creating a number that's less than 1. So what I'm going to do is rewrite it, but we need to move our decimal down to the left this time. So I'll put 5.1 over here on the right hand side, and we're bouncing the other way. 4 bounces this way. So once, twice, 3 times, 4 times, because we had minus 4. So our decimal goes in here. Now what do you think I do with all these spaces that we have? We add zeros, 0, 0, 0, and you can't just say 0.00051. You need to make it 0.00051. So we end up with 0.00051 kilograms.